But thank you.
What a jerk.
All right, next up we have Earl Joseph. Earl is Program Vice President of IDC's High Performance Systems and drives research and consulting efforts associated with the United States, Europe, and Asia Pacific markets for technical servers and supercomputers. Earl also heads up IDC's high-end HPC user forum activities.
Great, thank you much. So my slides will be available, so I'm going to be walking through them fairly quickly. We're generally asked to share some of our numbers, our recent market research, and things like that. So first of all, high-performance computing. Ooh, the projector is clipping the top. Sir. Smack it. Just smack it a little bit. Back to the same place. There we go, that's a little better. Might clip the bottom. So we're using high-performance computing to represent all those categories. It's basically anything that's a server. So it has to be a technical server used by scientists, engineers, financial analysts, and others for doing highly computational and data-intensive tasks. Same definition we've had for 25 years. Some of the new research areas, and I'm going to highlight a few of the interesting studies that we've been doing, but we're doing a lot of research, of course, on GPUs and all other types of accelerators, new types of processors. Big data, data-intensive computing, complex data, whatever term you want to use, we're doing a lot of research on that. I think most of you know Steve Conway, he's leading that on our side. We're working very closely with vendors and users around the world. And for those of you who are IDC clients, our big kind of landscape document will be available to you for reading within the next 10 days. We're doing a lot of work to try to figure out where clouds fit in HPC, where they don't fit, what the issues are, what the success stories are. We've been running our cloud panel at our user forums for the last 2.5 years. So we have a lot of good case studies there. We're finding a lot of issues with clouds and a lot of positive things, so there's a lot of trade-offs. One of the big issues right now with clouds is the price of running an HPC application on a cloud. It's anywhere between 5x and 25x of doing it in-house, and so we're trying to work through how that might change. Also, the needs and requirements of small, medium business and small, medium science organizations. The trends and directions in China and Japan. We've been under contract for a while now to visit all the top sites in China and Japan. Steve, I think we made 3 trips to China in the last 8 weeks, and so it's been a little bit of traveling. We're also working with the EU. Last year we did the study to help them figure out their HPC strategy for 2020. This year it's how can Europe really move all their software, HPC software, across all the countries more parallel and whole. And we're just starting a project with Korea to help the Korean government figure out how to be more productive in HPC and to actually apply it across the country. For those of you who aren't aware of it, Korea actually passed a law in their Congress that the country has to invest in HPC to make the country stronger and more healthy. So we're helping them actually put that together. And with that, I'm going to just invite everyone to attend our user forum meetings. If you want to download any of the presentations, it's a little hidden on the website, but if you click there, you'll see the slide decks from the last 8 years of meetings. So with that, I'd like to talk about some general economic trends. Looking at the big picture of IT, you can see we've been through a couple waves here right now. Last year, 2010, was a nice uptick year for the overall IT sector itself. IDC tracks all different types of categories. It's a combination of all of them. Our current projection is roughly around the 6-7% rate is what the general IT market we're expecting to grow at. But it's going to grow very differently by region. This is showing 2010 to 2011, where you can see certain countries are seeing some very different changes in it. As you can see, the smaller countries tend to have the higher growth rates, but they're growing from a smaller base. And with that as kind of a background of the overall IT market, what's going on, to talk about high-performance computing. 2010 was a very strong year. It grew by 10%. The market, the way we track it, is now about $9.5 billion. We are forecasting roughly a 7% growth over the next 5 years, but that growth rate is going to vary dramatically by the different sectors. There's still a lot of challenges for the end users. We spend a lot of time talking with both users and vendors around the world. The whole issue of power, cooling, floor space is just massive, but it's very different. It's a constraint. It's not like in the commercial sector where people are trying to save money on their power bill. It's a real issue of how quickly can I get my electricity up at my center. We're seeing a lot of centers that have gone to 50 megawatts, they're going to 100 megawatts and larger than that. Outside the US, there seems to be a stronger recognition that the future supercomputers are going to require a tremendous amount of power. And so we're seeing a tremendous build out right now on that part. So here's how the market worked out in 2010 and the first half of 2011. You can see the supercomputer segment has grown dramatically. It now represents almost 39% of the market. Over the last decade, this sector had been shrinking quite a bit, and there's been a very strong recovery. The recession hit the workgroup market, the lower end, more heavily. That has not really rebounded back very much. The one thing I should mention is the second half of the year is already stronger than the first half, so don't take this as an indicator that 2011 is an off year. We still think 2011 looks a very healthy year. This is the same numbers as far as units shipped, and here you can see the bulk of the units are still the lower end workstations, whereas the bulk of the revenues are on the supercomputer side. And for 2010, this is how the vendors ranked. We have, as far as the supercomputer segment, IBM continues to lead the supercomputer segment at 53%. HP is number 2 at 25%, and Cray at 7.8%. Cray had a very strong fourth quarter with one very large sale, and this week Cray announced another very large sale. So of all the vendors, the hardest one for us to actually forecast is Cray, because they tend to have one sale that's equal to a major portion of the revenues. So here's how 2010 looked by all the different vendors. HP's clearly been the market leader pretty much most of the years over the last 6 years. There was one year where IBM was market leader, but they've been both within a couple percent of each other. Here's how it looks for the second quarter 2011. IBM had a fairly good second quarter, so IBM's in lead at that point, but HP is still leading for the whole year. We do split by the different industry application segments, and so we're including the numbers here for that. I'd like to talk just a second about the broader HPC market. So we also track the storage portion, middleware application, and services. We don't include networking in this. I think you had in yours. And with these categories, we are seeing the market growing in 2010 to about $19 billion in total. And I'd like to show our forecast too. So this is the revenue and system units. As I mentioned, revenues we're expecting to grow about just over 7%, and units about 8.4%. We also include package. We're often asked how accurate are our forecasts, how are they changing, and so the green line is showing the new forecast. So we're getting a little bit more bullish in our forecasts. And overall, as far as the market numbers, we are pleased that 2010 is a year that returned back to growth. We've declared the recession over in HPC. We hope there isn't a double dip, but at the moment, the recovery is hitting the different segments somewhat differently. But there are still major customer pain points. Software is becoming the #1 issue, and you'll see, I'm going to walk very quickly through a study we did that for the EU, and this was really, the EU asked us to come up with a plan for how Europe as a whole could create a whole new software infrastructure to more parallelize all the codes in Europe. So don't think of this as, how do we parallelize the top 10 codes? The top 100 codes, this is the top 5 to 10,000 codes. So this is a very substantial initiative. And our proposal, recommendations, and all the research is available for free. And I'll show you the pointer at the end. So some of the key findings are things like, Europe already has a lot of good scientists, engineers, and a lot of good software. So they have the core foundations. But the underlying problem really is modern HPC hardware has just outstripped the software ability to take advantage of it. So if you download the report, it has everything as far as the landscape of Europe, the origin of the codes, who originally wrote it, which country. Here are the top applications at the various sites, how well they scale, all different types of metrics on scaling the code, who owns the code. An important thing if you're going to try to move codes forward, you need to know who the owners are to know whether you can invest and work with them. The programming environments used, you can see Fortran still dominates the world. It's within 75% to 80% of all codes out there right now in Europe. What's needed the most? And so then I'd like to quickly get into recommendations. So the first thing is, Europe has a window of opportunity to actually become a global innovation leader in software. And so the goal is not HPC leadership as far as itself, but HPC leadership to get advancement in science and engineering innovation. So it's the application of software to solving the problems. And so our recommendation is first to create a new EC body to coordinate the holistic parallel software approach. And what we mean by that is instead of having each university and each organization doing their separate investments, Europe as a whole needs to pick out a number of areas to invest in and actually have a coordinating body to move the funds there. The next one is to really fund the current centers of excellence to a much higher level and pick out which ones are going to take the lead, and to create a web-based parallel software clearinghouse. These are part of our recommendations that were somewhat different, and this is to create an eBay-like environment for the European software. So people who've written software codes, algorithms, and programs can actually sell them and make use for it. It's also a documentation of all the software out there, instead of reinventing the wheel. And so it's a whole mechanism for kind of a trading and understanding and training. The other part is to create a set of tiger teams that can actually go out and touch that. If you're trying to move, say, 1,000 software codes forward every year, you need a large number of people to go out there and find it, work with them, and help develop that. And we're recommending on the order of 100 teams, and the teams would basically be 2 people, a domain expert and a parallel programmer expert, that would go out and actually help each of these sites move it forward, but they'd also be the front-end arm for bringing that software then to the centers of excellence to really move them forward more dramatically. And of course, then spend the money required. For doing this portion of the recommendation, we're saying it's about 150 million euros a year additional investment. And the real message is on this, good exascale hardware in the future is really required, but the number one shortcoming today is software. And we need to, as a community, figure out how to address those problems. As I mentioned, if you go to the website here, the user forum/EU, you can download the entire report, the study, and all the statistics and work. What I'd like to do then is just very briefly in the last couple of minutes, I'm going to start going over the clock by a couple of minutes like Addison did, is just a few snapshots of what's going on across Asia and the rest of the world. So first of all, these are a set of charts just straight from the Chinese. First of all, they are planning to build 17 major petaflop supercomputing centers within the next 5 years. I think we visited about half of them so far. The first petaflop supercomputer, totally powered by a domestic processor, will be released in 2011. This was announced just a couple of weeks ago. There's actually going to be 2 of them out there very soon. The other recognition in China is that if you really want to lead in high-performance computing, it's a budget issue. In other words, if you want to have the biggest machine, you have to spend the most amount of money. So their mindset on the budgets, this is one example of one Chinese Academy of Science, moving their budget from 250 million to 1.2 billion. And this is very typical of the centers that we're visiting as we're tracking their budgets, and the growth rates are just staggering. By the way, Dawning has changed its name to Shugen because they're going to do IPO and actually go public with their stock. Interesting thing, they are on their 3rd generation of a personal supercomputer. So there's a lot of products in China that we don't hear about quite so much, but it's very fascinating what they're doing. Here's one of the systems that will be built with Chinese processors. This was announced about 6 months ago. And the Sunway Blue-Right is the more recent one. I expect to see more machines. There's 3 different processor developments in China right now as far as core computational processors. And again, I'd like to invite you to join us in our future meetings. And with that, I think I just went over by a minute or 2.